All right, guys, we have this problem where the one ball is launched after the other one vertically up in the air with different velocities, and we want to figure out when they meet. We want to do this mathematically. So just to kind of give you a little bit of background in what's happening. So the first ball is launched at 15 meters per second. So basically it does something like that. And the second ball is launched vertically at 12 meters per second, but it's launched 1.15 seconds later. So it's something like this. Okay. So now let's just get the information written down here. So we can keep track of everything while we go through this solution. So T1, the time that ball one is in the air for, and when they meet, okay, so they're going to meet right here. That time is equal to T2's time plus 1.15 seconds. So think about it. This is 1.15 seconds later. Okay, that's when the second ball is released. Okay, now total time that's happening here for T1. Okay, so this is T1. That's equal to T2's time plus 1.15 seconds. So when you're trying to figure out, where did I come up with that expression, that's where that comes from. So T1 is T2 plus 1.15 seconds. All right. Now we want to mathematically figure out the time that they get to that same height. All right. So what we're going to do is we're going to write the height equation for ball one, set it equal to the height equation for ball two. Now they both start at the same height, which is 0. So I'm just going to start my equation like this. So V initial, ball one, times T1 plus 1/2 gravity is the acceleration, T1 squared. Set that equal to the same expression, but now for ball two, which is V initial ball two times T2 time plus 1/2 gravity T2 squared. Okay. I have too many variables, so I need to substitute this expression up here in for T1 in these locations. All right. So let's do that. When I do that, this is what I'm going to get. V initial 1 times T2 plus 1.15 seconds plus 1/2 g times T2 plus 1.15 seconds. That has to be squared. That's equal to, this stuff on the right hasn't changed. Okay. So now when I look at this, I only have the variable of T2 in here, which is what I want to solve for. All right, that's the time for the second ball, which will allow me to figure out when they meet and how high they meet. Now, let's just do a quick check of some things here before I move on. Okay, that's a number, 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 and number. All right, we only have one variable, but it's in a bunch of locations. Sometimes it's being squared. So, we have to consider that. All right, first thing I'm going to do is I need to figure out this part right here. Okay. Now, you have to use the FOIL method. All right, first outside, inside, last. So let me just kind of do this out, show you what happens with this and what's going on. Okay. So we got T2 plus 1.15 seconds times, because it's all being squared, T2 plus 1.15 seconds. So we're going to do the first, okay, then the outside, inside, and last. All right. Excuse me. When we do that, I'm just going to write it out because I don't want to write out every single step here. What we're going to end up getting is we're going to end up with 1/2 g times T2 squared plus 2.3 T2, which is the 1.15 seconds times T2 on the outside and then also on the inside. So it comes out to 2.30 seconds T2 plus 1.15 the outside here, the last, 1.15 seconds times 1.15 seconds, which is going to give us 1.3225 seconds squared. All right. Equals, and we're just going to rewrite the top here. Okay, now let's take care of the left side over here. I'm going to take my V initial 1 and multiply it through. So when I do that, this is what I'm going to get. V initial 1, that's ball 1, times T2 plus V initial 1 times 1.15 seconds. And that's all being added to the rest of this stuff. Okay. Now, I need to multiply the 1/2 g all the way through here. Okay? So when I do that, this is what I'm going to get. I'm going to get 1/2 g times T2 squared plus 2.30 seconds over 2 times g T2 plus 1.3225 seconds squared divided by 2 times g equals, haven't had to do anything on the right side of this equation yet, the initial 2 times T2 plus 1/2 g T2 squared. Let's go back to the left side of the equation. Just going to recopy the things that we have here. So V initial 1 T2 plus, let's do it this way. Let's write it 1.15 seconds V initial 1 plus all that. Okay. So let's stop for 1 second. Let's just look and make sure everything looks okay and makes sense. All right. Okay. I'm going to do a little bit of simplification here. All right. So 2.3 divided by 2, all right, is really 1.15 seconds times gravity times T2 plus 1.3225 seconds squared divided by 2 comes out to 0.66125 seconds squared times gravity. I just want to get, I don't want to have fractions when I'm doing all this. All right, we can leave the 1/2 GT2 squared. We can leave that. That's fine for now. Okay, so I'm just going to rewrite everything so it's a little neater here. Okay, so we have V initial ball 1 times T2 plus 1.15 seconds V initial ball 1 plus 1/2 gravity times T2 squared plus 1.15 seconds G times T2 plus 0.66125 seconds squared times G equals V initial ball 2 times T2 plus 1/2 G T2 squared. Okay. So let's look at what we've got here as far as just numbers and variables and so on. All right, this, because I know the V initial of ball 1 is 15, this is going to end up being a number, all right? And the units are going to be seconds times meters per second, which is going to be meters. Okay, so that's fine. This over here is also a number, and the units we get from this one are going to be seconds squared times the units for gravity, which are meters per second squared, which is going to end up being meters. Okay, so these two things, you know, as far as collecting like terms, those can end up being on the same side of the equal sign. Now, the variable I'm trying to solve now is T2, so let's just identify all the places we have a T2, because we need to collect like terms here. All right, so what we got here, okay, so collect like terms with T2 on the left and numbers on the right of the equal sign. Okay, so let's do that. When we do that, this is what we're going to end up with. V initial 1 times T2 plus 1/2 gravity times T2 squared plus 1.15 seconds times gravity times T2 minus, because we're going to bring these terms from the right side over, minus V initial ball 2 T2 minus 1/2 G T2 squared equals, I'm going to bring my number equations over to the other side. So when I take 1.15 seconds times V initial 1 to the other side, it'll be negative. And when I take 0.66125 seconds squared times gravity to the other side, it'll be negative. So I'm going to write negative parentheses 1.15 seconds V initial 1 plus 0.66125 seconds squared times gravity. Let's make that a little neater. Seconds squared times gravity. Okay. Okay, let's look at this. Everything looks okay as far as bringing all the terms over together on one side of the equal sign. All right. So something I'm noticing here is I have a positive 1/2 GT2 squared, and I have a negative. Okay? So what that means is that this and this, they cancel each other out. So I'm just doing some simplification right now. All right, so this will help me get this a lot neater. So with those gone, my equation now becomes V initial 1 times T2 plus 1.15 seconds gravity times T2 minus V initial 2 times T2 equals negative parentheses 1.15 seconds V initial 1 plus 0.66125 seconds squared times gravity. Okay, so it's definitely getting a little neater here. All right. So we have T2 here, T2 here, and T2 here. We don't have any more T2 squares. So what I'm going to do is I'm going to pull the T2 out. So parentheses, V initial 1 plus 1.15 seconds times gravity minus V initial 2, close parentheses, T2 equals 1.15 seconds times V initial 1 plus 0.66125 seconds squared times gravity. Okay, quick check here. That's a number. That's 15 meters per second. This is 1.15 seconds times 9.8 meters per second squared. That's a number. Minus V initial 2. That's a number. That's 12 meters per second. Over on the right side of the equal sign, 1.15 times V initial 1. That's a number. And 0.66125 seconds squared times gravity. That's a number. Okay? Now, seconds squared times gravity, so that would be seconds squared times meters per second squared. That's going to end up being meters for the unit. Seconds over here, 1.15 seconds times 15 meters per second will give me meters. Now, on the left side, I'm going to have meters per second plus seconds times meters per second squared will be meters per second. So the units here are meters per second, and then the last one will be meters per second. So this is fine. So I'm going to have units of meters per second on the left and meters on the right, which means when I try to get T2 alone, I'll divide both sides by meters per second, which will cancel. On the right, we'll cancel meters and bring the seconds up to the numerator, which is the correct unit for time. So that all looks good. Okay, so let's put the numbers in and do this math out here. So 15 meters per second. Now 1.15 is going to be multiplied by negative 9.8 meters per second squared minus 12 meters per second T2. All right, equals negative 1.15 seconds times 15 meters per second plus 1.66125 seconds squared multiplied by negative 9.8 meters per second squared. So when I do this out, I'm going to get on the left here, I'm going to end up with negative 8.27 meters per second times T2 equals negative 10.76975 meters on the right. Divide both sides by negative 8.27, and we get a time of positive 1.30 seconds.